Why would we want to factorize a quadratic equation using the AC method? When we do this, it allows us to find the x values or zeros or roots of the equation in order for us to be able to factorize using this method. However, our equation must first of all be in that form there that I have on the screen. This form is called standard form. In some books, it's called general form. Notice it's ax squared plus bx plus c. A, b, and c are all real numbers. What the AC method allows us to do is to take the a term, or the a is really the coefficient on the x squared term. We take that a, whatever number it is, and we multiply it by c, whatever number c would be, and we find a product. The reason we will want to do this will become apparent a little later on. The first equation we're going to factorize is this one. 2x squared plus 5x minus 3 equals 0. Now the a, b, and c values of this equation are on the screen there. A is equal to 2 and b is equal to positive 5, c is equal to negative 3. In bracket, what I have there is a times c, meaning, oh, okay, what I have in bracket is a times c. A times c is 2 times negative 3. 2 times negative 3. And if we multiply 2 times negative 3, what we would get is a negative 6. So the product of 2 times 3 in the case of this equation yields a negative 6. Next step is to find two factors of negative 6 that will add or subtract to give us positive 5. Why would we want to do that? I did say it would become apparent as we go along. Let me make this clear. The middle coefficient is 5. Right now, the quadratic is in the form of a trinomial. It has 3 terms. What we want to do is to add one more term to this quadratic and bring it to 4 terms, to make it 4 terms. The advantage in doing that is when you have a quadratic that has 4 terms in it, you could then group it into 2 binomials. And when it is grouped like that, we're allowed to use factorizing by grouping to solve it. So let's go back to the equation we have on the screen there. 2x squared plus 5x minus 3. We have found that a times c is negative 6. We want to add one more term to this equation. And the best way to do it is to split that middle term into 2. Positive 5, we split it into 2. And we use the factors of negative 6 to do so. Those factors of negative 6 that add to give us positive 5, we then use to rewrite that, that term, 5x, as 2 terms. So let's play around with the factors of negative 6. We can get 1 times 6 will give us a positive 6. If we make either of those two, either 1 or 6, negative, we will get a negative 6. But what about if we want to get a positive 5 from that 1 and that 6? What we will have to do is to add a negative 1 to a positive 6, and that will give us a positive 5. And those two factors, negative 1 and positive 6, are the two factors we are going to use to rewrite the middle term as a binomial instead of a monomial, thus turning the left-hand side of this equation into 4 terms that can be grouped into 2 binomials. So let's go ahead and rewrite the entire equation as a matter of fact, like this. Notice what we have on the screen there now. 2x squared, and guess what? We have rewritten that 5x as positive 6x minus x. So we have 2x squared plus 5x minus x is equal to negative 3, plus negative 3, that is equal to 0. So those four terms can now be grouped into two brackets, making two binomials like this. In the first bracket, what do we have? 2x squared plus 6x. In the second bracket, we have negative x minus 3. Factorizing by grouping allows us to factorize each one of these binomials separately, as I said, using different GCF, greatest common factors. For the first bracket, we notice that we have 2 and 6. And the greatest common factor between 2 and 6 is 2 itself. The greatest common factor between x and x squared is x. Now, using the quotient rule, we can say that 2x into 2x squared would leave us an x. We bring down our positive sign. 2x into 6x will go 3 times. So we have factorized the contents of that first bracket there. The second bracket, let's be a little careful with this one. We have a negative x and a negative 3. The only thing common here is a negative 1. And negative 1 will go into negative x and leave us a positive x. Negative 1 will go into negative 3, a positive 3 times. So the two GCF, 2x and negative 1. Looking at the two brackets there, the contents are identical. At this stage, we are allowed now to factor out the contents of the two brackets as one binomial because the contents of the brackets are common. So now we can have the contents of the two brackets, x plus 3 in one bracket, a bracket by itself, and then the two GCF, 2x minus 1 in another bracket. So we can rewrite like this. Notice we have x plus 3 in one bracket, 2x minus 1 in another bracket. From here, what we can do is set each one of those two binomials equal to 0 and solve for x, because remember we said that we need to find the values of x. By the way, the roots of the equation usually has two x values. So we're going to end up with two values for x. Let's find the first value for x. In the first bracket, we have x plus 3. In order to solve for x, we need to get x by itself. So we have to subtract the 3 from the left side. So we have x plus 3. And if we subtract the 3, we get a negative 3 there. And then that will be equal to negative 3. On the left side, the 3's will cancel each other out. And so we will be left with x is equal to negative 3. The second binomial is 2x minus 1. Let's write that down. 2x minus 1. In order to get rid of that 1, so we could get x by itself, we need to add that 1 to both sides. So we have a situation where we have 2x minus 1 plus 1 is equal to 1. On the left side, the 1's will cancel out, leaving us with 2x equals 1. We're almost there, but not quite, because the x still has the coefficient on it. It still has a 2 on it. So what we have to do is to divide both sides by the coefficient on the x, meaning dividing both sides by 2 in order to get x by itself. How do we do that? We write it this way. So we have 2x divided by 2. 2x over 2 is equal to 1/2. Simplifying that to find the other value for x, we would find that the 2's on the left side will cancel each other out, leaving us with x. And x will be equal to 1/2. So we have two values for x here, -3 and 1/2. So we could write our solutions nicely as x equals -3, x equals 1/2.